Good day everyone! I am Duff Matthew P. Mananghaya and I am from Grade 12 STEM 1901. In this video, I am going to discuss the hazard map and the hazard matrix of my community, which is the Barangay 412, Zone 42 in Sampaloc, Manila. As we can see here on the screen, at the end of the video, we will learn about the hazard map, the legends, and the hazard matrix. Let's get into the discussion. First, we have flood. So let's first define what is flood. A flood occurs when water overflows and submerges normally on dry land. Floods are a topic of research in the field of hydrology. They are by far the most common and widespread natural occurrence of severe weather. Floods can take on a variety of shapes and sizes, ranging from a few inches to several feet of water. So in my community or in my barangay, generally it is moderately susceptible. Knowing that some streets and some places here in our community are moderately low, and the most common thing that triggers the occurrence of flood is the black sewerage and canals. But to be specific, the street that my house belongs are not that affected by flood whenever there is a heavy continuous rainfall. And as we can see on the given legend, our community are moderately susceptible to flooding. Next hazard is the soil liquefaction. So what is soil liquefaction? Soil liquefaction, it is also known as the earthquake liquefaction. It is the temporary transformation of normally stable soil into a viscous liquid due to the ground collapse or loss of power. The phenomenon occurs in unconsolidated water or simply the saturated soils that are subjected to seismic waves that triggers ground vibrations during earthquakes. So as I assessed, the community is highly susceptible to soil liquefaction. Why? Because certain areas or places here in our community is near football fields, especially in University of Santo Tomas or UST. Some areas in Malacanang and Menjola are highly susceptible to soil liquefaction. Jumping on to the next kind of hazard, which is the active faults. So basically, active faults are a fault that is likely to become the source of another earthquake sometime in the near future. So as seen here on the slide, the active faults is particularly located near my place at Lavandero Street. It is pretty close to the Social Security System or the SSS branch here in Ligarda. Lumera Tower, which is also close from our home, is declared to have active faults. Also included is the Santa Catalina College, which is my previous school. So as seen here on the slide, at this moment, I am now going to pinpoint some of the areas near the community that is potentially active, and inactive faults. So as I have said earlier, active faults are located somewhere in Lumera Tower, Santa Catalina College, and SSS branch here in Ligarda. But to add, here are the potentially active and the inactive volcano hazard. Potentially active volcano hazard is located near San Beda College, and the inactive volcano is at the Arellano University in Juan Sumulong campus. To specifically locate all of the exact hazard places, here are some. This area in España, Manila is obviously and undoubtedly prone and hazardous to flood. During the school days, many students are stranded there because of the massive flood during rainy seasons. Next is in the place in somewhere in Moraita, Manila that is prone to flood too. Let's go with soil liquefaction. As I have said earlier, this particular area is hazardous to soil liquefaction. The one is from University of Santo Tomas or in UST, and the one is from Malacanang in Menjola, Manila. For the exact location of active faults, here are some. These are the exact place where active faults are located. The condominium in Ligarda, which is the Lumera Tower, and the San Lorenzo Ruiz Student Center in the same location. Let's go on with the fire. These are the places that are prone to fire incidents. Why? Because as we can see, the house was made from light materials and made from wooden materials. That is specifically located at Lardizabal Street, one street away from our street, and the one in Ligarda Street near the LRT station. To add, it makes the area more hazardous to fire because the houses at the back of the house from Lardizaba Street are very crowded and are also made from light materials. So let's go on with seismic hazard assessment. Nearest active fault, Valley Fault Systems, West Valley Fault, 8.2 kilometers. Ground rupture, safe. Ground shaking, prone, intensity 8. Earthquake-induced landslide, safe. Liquefaction, high potential. Tsunami, safe. Next one is the volcanic hazard assessment. Nearest active volcano is Taal Volcano. It is from 65.4 kilometers away. Nearest potentiality active volcano in Corregidor, 51.4 kilometers, no immediate volcanic hazard threat. Kilometer radius outside, ballistic projectile safe, base surge safe, volcanic tsunami safe, nearest inactive volcano, Talim, part of Laguna. Let's now go in the hazard matrix. So let's first start with the first type of hazard, which is the typhoon. The typhoon is almost monthly from June to September. The duration of the typhoon is 4 days. Speed onset in 96 hours. Intensity or magnitude, storm signals from number 1 to number 3. Probability, 80% it passes through the community. Forewarning, signals include strong winds and dark clouds. There is enough time to observe the weather before its occurrence. And its manageability is from signal number 1 up to signal number 2 is still manageable with enough preparation. Signal number 3 requires more attentiveness. This type of hazard is flood. So the frequency of flood is every time there is an extreme rain once every 3 months. The duration of flood is 3 hours. The speed onset of flood is 2 hours of continuous downpour. The intensity of or the magnitude of flood level is ankle deep. The probability of flood is moderate due to the continuous rains. The forewarning of flood, extreme rainfall, overflowing of water sewerages. And last one is the manageability. The manageability of flood is manageable if plan is properly executed. So let's go now with the type of hazard, which is the earthquake. The frequency of an earthquake is average of 2 earthquakes per year. The duration of an earthquake is about 20 seconds. The speed onset is unpredictable. The intensity or the magnitude is from magnitude 2 to magnitude 5. The probability of an earthquake is around 60% are felt by the community. The forewarning of an earthquake is to moderate shaking of the ground. The manageability of an earthquake is safety or safely manageable if primary plan is well executed. Let's go now with the common type of hazard, which is the fire. So the frequency of fire is mostly happens during summer season. The duration of fire is from 3 hours if not responded immediately. So the speed onset for the fire is as quick as 3 minutes. Intensity or the magnitude is from moderate to extreme fire. The probability of fire is 60% of occurrence of fire. The forewarning is loud noises, fire alarms are detected, definite smell of the burnt materials, and last one is the manageability. Not manageable because of lack of proper knowledge on first aid and in survival.